Hello guys, so today this is my first ever educational video that I'll be teaching and giving you guys free access to, and it's of course always free, and I won't charge you because I'm doing it as a hobby. So for this video I'm going to share with you about the scientific method, and which is a method of studying science and learning about discovering theories and laws of science. Let's get started, shall we? Before that, I would like you guys to know that this is actually my second take on this, because yesterday I filmed everything and I messed up and I deleted all the scripts. So I'm right now free flowing this, and I spent 5 hours editing and somehow it failed again. Anyways, so let's get onto the definition of the scientific method. What is the scientific method? The scientific method is a method of research in science using experimentation and evaluation. The scientific method consists of 4 steps. So the first step is to create a statement that tries to state an observation or a pattern, and create a guiding question to direct you to answering the observation or pattern that you have seen. The second step is to create hypothesis. You can have as many hypotheses as you want, but try to keep it to a few hypotheses. Hypotheses are smart guesses that tries to answer the guiding question and explain the observation or pattern. Why does it happen? And the third step is to experiment. You need to have many setups for your experiment, and you try to predict the outcome before the experiment so that you can evaluate whether the outcome is right or wrong. And if the outcome is right or wrong, we will go on to the next step. So next step is evaluate. If the outcome is right, then of course your hypothesis is supported and your hypothesis is valid. So if your hypothesis is valid, you can use it to answer your initial observation, or you can use the hypothesis to continue on with other experiment, which we'll talk about later. And let's get more in depth into the steps of the scientific method. The first step is about observation. So you have to create a statement about your observation. So let's say, for example, on the paper I've written ice. So when you take ice from freezer, you'll notice that the ice melt if the room temperature is above 0 degrees Celsius. So that's your statement. And for the guiding question part, we try to answer why does the ice melt. So the guiding question create a direction that answers that. So our guiding question is, why do the ice melt in the room? So the second step is to form the hypothesis, and you can have as many hypotheses as you want, but like I said, keep it into a few. So I have 2 hypotheses in the paper that I've written. One of it is obviously false and one of it is obviously true. I keep it at 2, but you can have as many as you want, like I mentioned. So hypotheses are basically guesses that try to answer the guiding question and tries to explain the observation. And for my first hypothesis is the not valid one, which I talked about. There's an invisible force that crushed the ice to make it melt or something like that. And for that is obviously false. And the second one is the one that is correct, which the ice melt because the room is warmer and the ice will gain energy to overcome its forces of attraction if you get more in depth to it. So the third step is experiment and predicting the outcome for the experiment. For the ice setup, for the ice experiment, we have 3 different setups, and each setups must have 3 different variables. The 3 different variables are control variable, independent variable, and dependent variable. Control variable is the constant variable that is the same throughout all your setups, and the independent and dependent variable are the one that is different. They are your actual variable. For your independent variable is the variable that you change throughout your setup, and they are always different. For the dependent variable is dependent on the independent variable. That means the input X will give it output Y, when output Y is your dependent variable. So for example, we trying to measure the rate of transpirations for plants. We have 2 different setups. One with different light, 2 of the different setup have different light intensity. One with higher light intensity, the other one with lower light intensity. So you'll notice the higher light intensity setup will have higher transpiration, while the lower light intensity setup will have lower transpiration. So the rate of transpiration for the one with higher one will be higher, of course. So the rate of transpiration is the dependent variable, where the independent variable is the light. So you usually measure the dependent variable itself. So for the setup, we can have as many setups as you want, but minimum we keep it 2. And try not to have as many setups as possible. But you can have as many setups as possible, but try not to, because you have a lot of data to organize. So for the second part, we'll be predicting the outcome. So it's simply just predicting the outcome of the whole entire setups. So for the ice experiment, our outcome that I predicted will be the room with the highest temperature, the ice will melt the fastest, will take the fastest time to melt. So that will be the outcome that I predicted. Of course, if you do not know the actual outcome, you wouldn't predict the outcome to be like that, assuming it's a discovery science or something that we're trying to discover, something that we haven't known before. So we have to actually predict. So for this one, I of course know the outcome, so I predict the right outcome. So lastly, the 4th one will be evaluation. Forgot to mention, the predicting outcome part, the outcome must be based on your hypothesis. So assuming you testing hypothesis 2, then we'll base it on the hypothesis. So for the ice experiment, I'm testing it with hypothesis 2. So the outcome I'm predicting will be based on the hypothesis 2. Back to the topic, if the outcome is right, then your hypothesis is valid. So if the hypothesis is valid, you do not need to test anymore. But you can test using the hypothesis. You can test it if you're not satisfied with the hypothesis to explain your observation. You can test it even further to get more different hypotheses that is valid to find the correct hypothesis to explain your actual observation. If the hypothesis is valid and it satisfies your explanation, you can just stop the experiment right there. And lastly, the last possible outcome is that the hypothesis is not valid, so we'll move on to the next hypothesis. And if we run out of hypothesis, we'll repeat from step 2 of the experiment again. Or perhaps we'll just try to observe the experiment. Go back to step 1 and observe whether is our eyes the one that deceive us or there's more to it. So that's all for the 4 steps of the scientific method. And now we are going to talk about the differences between hypothesis, theory, and law. And we are also going to talk about model. Hypothesis is a smart suggestion that tries to explain the initial observation without knowing it. So we are going to test the hypothesis to try to answer it and validate. Theory is an explanation that has been tested and confirmed. So a hypothesis can be a theory if it's tested enough, that is confirmed, and it's valid throughout the whole entire test or most of the test. Law is an observation statement that always appears true. So unlike theory and hypothesis, law doesn't try to explain. Law is just state. So for example, a law would be light in a vacuum travels at a constant speed, and we don't try to explain that. So to summarize quickly, hypothesis is an explanation, a suggestion that tries to explain an observation that is not tested yet. Or if it's tested and validate enough, it can become a theory. And theory is basically an explanation that tries to explain the observation but it's 100% valid. And lastly, we got a law, which is an observation statement that does not explain, it just observes and it's always true. Now we are going to talk about model. Model is a representation of something that is hard to show or impossible to show directly. So for example, for a model that is hard to show directly is organ. So you can't just take out a stomach from a human and show it in class directly for lecture. You also for heart also you can't do that. So like also blood vessel, you can't just take, because blood vessel is hard to show directly also. So for biology we use a lot of models. And for physics or chemistry wise, let's say crystal lattice structure of an ionic compound, we can't show directly because atom is a theory, so we can't show directly. A theory is true but it's not factual that it can be shown. There are 2 different logical thinking or reasoning used in science. Number 1, we have inductive reasoning. So what is inductive reasoning? Inductive reasoning is a reasoning that is done by gathering evidence and put in the form of data and put it together to form an inference. And number 2, we got deductive reasoning. Deductive reasoning is a reasoning done by using something that is already proven, such as a law or theory, to create an inference for something. Both reasonings are used in science, but they are used in different aspects of science. So for example, deductive reasoning is used to create hypothesis, inductive reasoning is used to discover something new. But both of it still, in the end, relies on the scientific method. So yeah, that's all for today's video. And I hope you learned something new. And if you did learn something new, please leave a thumbs up in the like button and subscribe if possible. And that's all for today's video. Peace out.